Today we will start with interferometry. Okay, am I audible?
Yes, sir.
Okay, fine. Okay, so we'll start with interferometry. So this is what we say. Just note down the heading as interferometry. So as per the syllabus, it is only mentioned about regarding the laser. Okay, regarding the laser interferometer. But before that, I will just tell you. I want to tell you just what you mean by interferometer. So this interferometer also comes under a topic which we have discussed yesterday. Can anyone of you tell me what was the topic yesterday we were discussing about? Anyone of you attend the class? Can you tell me what was the topic yesterday which we were discussing about? Okay. Whatever topic we were yesterday we were discussing about in the case of interferometer. Any one of you, Vishnu EP, could you just recollect what we were saying about?
Surface roughness.
Yeah, surface roughness. So it was like the advanced measuring systems. You remember the advanced measuring systems, and we were studying about the various types, right? Remember, Vishnu?
Sir.
Yeah, and today we are going to study about an advanced machine system only, but as it is like we can name it as interferometry. But as per our syllabus, it is defined as only about the laser interferometers. But here we are going to discuss about the laser interferometers. Okay, so here what we start with interferometry. So device in which electromagnetic waves are superimposed in order to extract information about the wave. That's what we say. Okay, so what is mean interferometers? It is mainly the electromagnetic waves which are superimposed in order to extract information about the wave. So what happens in the case of interferometry? It is it is an innovation, or it's information in which two waves which also forms a resultant wave of greater and lower amplitude. Okay, so in that ways also we can say this device in which electromagnetic waves are superimposed in order to extract information about the wave. Okay, so in the case of interferometry, device in which electromagnetic waves are superimposed in order to extract information in order to extract. Okay, so device in which electromagnetic waves are always superimposed in order to extract information about the wave. That's what we say, in order to mainly to extract information about the wave. So what happens is like interference means the phenomenon in which two waves, there are two waves, the phenomenon in which two waves form a resultant wave of greater or lower amplitude, form a resultant wave of a greater or lower amplitude is called interference. Of a lower or greater amplitude is called interference. So here what happens is we have astronomy, fiber
Hello, sir. Katai.
Though the small net connectivity issue, okay, so I have just lost it. By the meantime, am I audible?
Yes, sir.
Anyone, please? Okay. So we were telling about interferometry. So now what we are saying is about the gravitational wave. Okay. Now what we are saying about it is all about the gravitational wave. Okay. It's all about the gravitational wave. So what happens is the ripples in the space-time that propagate out of the speed of light. Okay. Then colossal cosmic collisions and stellar explosions can rattle the space-time itself. That's what happens over here. And the the Einstein first predicted in its general history. Okay, the Einstein first. Okay, so what's gravitational wave is ripples in the space-time that propagate out of the speed of light. Then colossal cosmic collisions and stellar explorations can rattle space-time itself. And Einstein first predicted it is in general theory of relativity. So after 100 days, prediction came true. It was detected on 14 September 2015. So this is what happens in gravitational wave. So what are the sources? Okay, now we will come with what are the sources and how are they detected. Okay, so this is what happens over here. So what happens normally is we have a mirror, we have a detector arm, beam splitter, detector arm, mirror, everything, and the gravitational wave and the normal situation, no signal, everything. So how do we detect this? Like, okay, Big Bang, that is 13 billion ago, to see something, 13 billion light hours, we must capture the light that we with. For the first 13 and 13,800 years of the universe, light could not break free. It was dense and immense. So gravitational was there. So we can analyze the property of early universe. So when it comes to the case of interferometry, application in engineering and applied science, okay. So Newton's interferometry is frequently used in optical industry. So I hope so. Before knowing go to optical industry, we had a brief description about what of the various. Can anyone relate me? Before going into the optical industry, we had a brief discussion of the optical measuring instruments. I hope so you remember what are various types of optical instruments. So in the same module. So what happens is in the Newton interferometry, it is frequently used in the optical industry for testing the quality of surfaces as they are being shaped and figured. So in telecommunications, wavelength division, multiplex, depending on the filtering devices that are thin film. So in the case of interferometers are the base of wide variety of devices with RF modulators, okay, with RF modulators to sensor to optical waves. So what happens? High precision examination of surface topography in the field of microelectronic and micro-optical fields are occurred. So what happens in the case of interferometry? Okay, interferometry is what? It's all we can always say it's an instrument which generates and combines the difference between the two light waves which are reflected off to two different surfaces, and it utilizes the effect of interference. That's what happens in the case of interferometry, where it's an instrument which generates and compares the difference, okay, between two light waves. Okay, it is always between the two light waves which are reflected of two different surfaces, and it utilizes the effect of inference, and it always utilizes the effect of interference. That's what happens in the case of interferometry. Then here it is a method for the accurate measurement of linear dimensions using a pure monochromatic light source. What happens is it is an interferometry is a method for the accurate measurement of linear dimensions. Okay, so interferometry means it makes the use of principle of superimposition to combine waves in a way that will cause their combination to have some meaningful property that is diagnostic to the original state of the waves. That's what happens in the case of interferometry. So, and there are various other techniques also, like holographic interferometry, high precision examination. All that factors comes into consideration. Okay, that's what happens in the case of interferometry. Then, now we will have a discussion about a topic which is named as laser interferometry. Okay, it is named as laser interferometer. Okay, that's what we laser interferometer. That's the topic which we are going to discuss today. So before that, we had a small discussion about what you mean by interferometer. Okay, now In the case of laser interferometer, what is laser interferometer? Today we are going to discuss about what is laser interferometer, then the principle of standard of interferometer, then the types of interferometers, then applications. So in this case, we will be mainly learning about the laser interferometer. So in one word, what we can say, laser interferometer, the instrument used for high precision measurements, that is distance, angles, etc. Okay, that's what we case K in the case of laser. It is used to interferometry as the basis of measurement. Then it uses very small, stable, and accurately defined wavelength of laser as a unit of measure in the case of laser interferometer. So what happens in the case of laser interferometers, like, okay, laser interferometers, like, it's a conventional light source emits waves of differing frequency of different times from different points in the source. So what happens here is a DC interferometer system mixes out the phases of light that beams. So what we have here, in simple words, what we can say, the instrument used for high precision measurements, distance, angles, etc. But it uses interferometer as the basis for measurement. So in that, what you I hope so you remember what you mean by interferometer. But a DC interferometer system mixes out of phase light beams of same frequency, whereas the AC system mixes of two slightly different frequencies, permitting the distance information to be carried on AC on the waveform. So what happens over here is the AC systems uses a source containing two frequency components. Mainly the AC system uses a source containing two frequency components located close to each other, creating each phenomenon whose amplitude variation can be made much slower than the radiation frequency. That's what happens in the case of laser interferometer. Okay, that's what happens in the case of laser interferometer. So, okay, so what happens is the instrument used for high precision measurements, the distance, angles, etc. Then it uses interferometry as the basis for measurement. Then it uses very small, stable, and accurately defined wavelength of laser as a unit of measure. Then this is what happens in the case of, see, this is the laser beam where we have double slit, and this is the viewing screen. So this is a symbol representation of interference of light with respect to the interferometer, with respect to the laser interferometer. So the basic principle of working of a laser interferometer is mainly regarding the interferometer. So I hope so you remember what you mean by interferometer. Can anyone of you tell me in a small way what you mean by interferometer or interferometry? Interferometry? Anyone? Can anyone of you tell me? Mohammed Asaf, can you tell me what you mean by interferometer?
Sir.
Asaf, can
Yes,
you
sir.
tell me what you mean by interferometer?
Measuring device. Sir.
Okay, but can you tell me what it generates and compares? What does it compares? I've already told now. It's an instrument
To extract information.
to extract the information of what? Please tell it precisely. Anyone, can you tell me precisely what you mean by interferometer? What Asaf told is almost right, but it's a vague idea. So you have to tell it specifically. That's what I'm asking. What do you mean by interferometer?
Electromagnetic waves in superimposed.
Yes, yes. So it is an instrument. Okay, it is always an instrument which generates and compares. Okay, the difference between two light waves, that is electromagnetic waves, which are reflected off two different surfaces. Okay, which are reflected off two different surfaces. That's what we say. Okay. So with respect to the message review, we are going to discuss about the laser interferometer. Okay, sir. So in the case of laser interferometer, okay, the case of laser interferometer, what happens is like what you are told. In the case of laser interferometer, a DC interferometer system mixes out the phase light beams of the same frequency. So a DC interferometer system, in the case of a DC, in the case of laser interferometer, a DC interferometer system, a DC interferometer system mixes out of phase light. Okay, mixes out of phase light the beams of same frequency, mixes mixes out of phase light than the beams of same frequency, whereas the AC system, whereas the ultraviolet system mixes the beams of two slightly different frequency. Okay, mixes the beam of two slightly different frequencies, permitting the distance information. Okay, permitting the distance information to be carried on AC waveform, permitting the distance information to be carried on the AC waveform. The AC system uses a source containing two frequency components. What happens is the AC system uses a source containing two frequency components. What happens over here is we have an AC system which uses a source containing two frequency components located close to each other, creating a heat phenomenon whose amplitude variations can be made much slower than the radiation frequency. So what happens over here is we have a laser beam, then we have a double slit, then we have a viewing screen, a plane wave is sitting on the double slit, then waves spread out behind each slit, top view of the double slit, the waves interfere on the region where they overlap, then bright fringes occurs where the antithetical light is intersect with the viewing screen. This is what happens with respect to the case of the review of interference of light. Then in the case of laser interferometry, the main components are two frequency laser sources are available. Okay, two frequency laser sources are available. Then we have optical elements, that's called the beam splitter, beam benders, and the reflectors. Then laser heads, measurement receiver, then measurement display. These are the main components of a laser interferometer system. In the case of a laser interferometer system, we have two frequency laser source. Okay, we will be having two frequency laser source. The second one is optical elements. Okay. Optical instruments. In the case of optical instruments, it is a beam splitter. Second one is a beam benders. The third one is a retro reflectors. And these are the case of optical elements. Third one, it is a laser heads measurement receiver. The third one is a laser heads measurement receiver. And fourth one is a measurement display. Okay, fourth one is a measurement display. This is what happens in the case of laser interferometry. Okay, then two frequency laser source. This was the first component, two frequency laser source in the case of laser interferometry. So in the case of laser interferometry, it consists of a two frequency laser source. So it is generally helium and neon type that generates stable coherent light beam of two frequencies. Okay, it is generally the type where that generates stable coherent light beam of two frequencies. One is polarized vertically and another horizontal relatively to the plane of the mounting field. So this is what happens with the case of two frequency laser source. Mainly it consists, okay, two frequency laser source. Okay, so it mainly consists, okay, what consists is generally consists of two generation stable as a coherent light beam of two frequencies, one polarized vertically and another horizontally relative to the plane of the mounting field. Then laser oscillates at two slightly different frequencies. What happens? Laser oscillates at two slightly different frequencies by a cylindrical permanent magnet around the cavity. So here what happens is we have a laser oscillates at two slightly different frequencies by a cylindrical permanent magnet around the cavity. Then two components of the frequencies are distinguished by their opposite circular polarization. So here what happens is the two components, okay, the two components are different by the circular polarization. So that's what happens. Okay. So here in the case of two frequency. So what happens here is like what happens. Okay. So here what we use HENE laser that generate the stable coherent light beams. Generate the stable coherent light beams with of two slightly different frequencies. Okay. Then the two frequency components are distinguishable by their opposite circular polarization. Okay, that's what we say. Opposite, the two components become distinguished by their opposite circular polarization. Then what happens? The beam, okay, always the beam always passes through a quarter wave plate and a half wave plate, which change the circular polarization. Okay, which change the circular polarization to linear perpendicular polarization, one vertical and other horizontal. So what happens over here is one polarized and another vertical related to the plane of mounting. What I can explain it, what we say is the beam passes, here in this case what happens, the beam always passes through a quarter wave plate and a half wave plate, which change the circular position to linear perpendicular polarization and vertical and horizontal. This is what happens in the case of the components. The component first one is a two frequency laser. So that's what happens. Then the second one is regarding the optical elements. Okay, the second one is regarding the optical elements, which we have the three types. That is one was the beam splitter. Then the second one was the beam bender, and third one was the retro reflectors. These are the three components which comes under the optical elements, which are the optical element is a what happens is the components used in the laser interferometer. So what happens in the case of an optical elements or beam splitter is, see, the below figure shows the beam splitters to divide laser output along different axes. Okay. So in the case of beam splitter, the below figure shows the beam splitter to divide laser output along different axes. So these divide the laser beam into separate beams. So what happens is here it shows the beam splitters to divide laser output along different axes, and these divide the laser beam into separate beams. So see here we have axis 1 and axis 2, and this is the axis 3. So the percentage. So in the case of beam splitter, okay, what happens? Beam splitters divide the laser beam into separate beams along different axes. So one word one can say, the beam splitters is used to divide laser output along different axes. That's what it is, into separate beams along different axes. So these divide in the laser beam into different beams. So the commonly used form of beam splitters is partially the reflecting metal or dielectric film on a transparent substrate. Okay, so what happens here? Other forms are polarization prisms and diffraction gratings. So the splitters lasers output intensity can be adjusted by having a choice of beam splitter reflectives. So that's what happens over here. So in the case of a beam splitter, it shows the beam splitters to divide the laser output along different axes, and this divide the laser beam into separate beams where the beams where the separate beams. Okay, so the where the divide the laser beam into separate beams along different axes. So the commonly used, okay, the commonly used, what happens? Commonly used form of beam splits partially reflecting metal. It's mainly partially reflecting metal or dielectric film on a transparent substrate, and other forms of polarizing prisms and diffracting gratings. So this is what happens in the case of a beam splitter. And the second one was the beam benders. The second one was the beam benders. So these are usually what we can say flat. Okay, these are usually flat mirrors having very high reflectivity. So here these are used to detect the light beam around the corners on its path from the laser of each other. They're actually just flat mirrors, but having absolutely flat and very high reflectivity. Okay, then normally these are restricted to 90% beam deflections to avoid disturbing the polarization vectors. So this is what happens in the case of a beam benders. That's what they are usually flat mirrors, sorry, having very high reflectivity. This comparatively having very high reflectivity, and they are used to detect the light beam around corners on its path from the laser source to each one. So what happens over here is beam benders. They are usually flat mirrors having very high reflectivity. Okay, just flat mirrors having very high reflectivity, and they are used to deflect the light beam, and they are mainly used to reflect the light beam around corners on its path from the laser source to each one, from the laser source to each one to each axis also. So normally these are restricted to 90% beam deflections to avoid disturbing the polarization vectors. Okay, so normally these are restricted to maximum of 90% the beam deflections to avoid disturbing the polarization vectors. Then the third one is the retro reflectors, which this also comes under the optical elements, the retro reflectors. So what happens over here is the retro reflectors is like the case of retro reflectors. It is a device. Okay, it is a device. In the case of a retro reflector, it is a device. What happens? It is a device or surface that reflects the light back to its source with minimum scattering. Okay, with the minimum scattering. That's what we say in the case of retroreflectors. So a retroreflector is always, sorry, a retroreflector is a device or a source. Okay, a retroreflector is a device or a source that reflects. Okay, the reflector is a device or a surface or source that reflects the light back to its source. The light back to its source with minimum scattering. It is always with the minimum scattering. It is always with the minimum scattering. Okay, light with also it always with the minimum scattering. Okay, with the minimum scattering, that is the reflected beam is always parallel. Okay, the reflected beam is always parallel to the incidental beam but opposite in directions, that what happens in the case of a retroreflector. So it is a device or a surface. Okay, it is mainly a device or a surface that reflects the light back. Okay, it is mainly a device or a surface that reflects the light back to its source with the minimum scattering, that is the reflected beam is parallel to the incidental beam. So here what happens is, it is the reflector can be, this can be also plane mirrors, roof prism, or cube corners which are three mutually perpendicular plane mirrors, and a reflected beam is always parallel to the incidental beam. That's what happens in the case of a reflector, where it is a device, okay, or it is a device or a surface that reflects the light back to its source with minimum scattering. That's what we say. Okay, cube corners will be also possible. Scattering. That is, the reflected beam is parallel to the incidental beam. Okay, the reflected beam is parallel to the incidental beam, but opposite in direction. Then they can be, what happens? They can be plane mirrors. Okay, they can be plane mirrors, roof prism, or cube corners. Which are three mutually perpendicular plane. Okay, which are three mutually perpendicular plane mirrors, and a reflected beam is always parallel to the incidental beam. Where a plane mirror acts as a retroreflector only when it is exactly perpendicular to the wavefront. It's always exactly perpendicular to the wavefront. Then cube corners are always set to three perpendicular plane mirrors placed from the corner to the cube. This is what happens in the case of a retroreflector. So all the this three, what are the three optical instruments which comes under laser interferometer? What are the three optical instruments which comes under laser interferometer? Agash came. Could you just tell me what are the three optical instruments which comes under a laser interferometer? Agash.
Hello.
Uh, what are the three components of optical elements which comes under a laser interferometer? Now we are describing what the components of laser interferometer. So in that we have discussed the second point as optical elements. The optical elements again we have subdivided into three parts. Can I just name it?
Sir, optically,
Ah.
sir, പറഞ്ഞില്ല.
ഓർമ്മയില്ല. Any one of you say what are the three components of the optical elements? Rahul, could you just tell? Rahul Rajiv, could you just tell me? The case of optical elements, and just name the three components. I hope so. You know that it's a component under laser interferometer, the optical elements. The optical elements we again subdivided into three. Yeah.
Beam splitter.
Beam splitter, correct. Then beam splitter, the two more.
Beam bender.
Yes, beam bender, correct. Then third one. Just now we have discussed third one.
Reflector.
Yes, retroreflectors. Okay, so these are the three components. Okay, so Agash, please listen carefully in the class. So this is what happens. Now, in the case of description of component used in laser interferometer, we have components like two frequency laser source, which I have described, then optical instruments. The third one was the laser lens measurement receiver. Okay, laser lens measurement receiver. That was the third one. And the fourth one was the measurement display. By this, we will be discussing about the what happens, the laser interferometer parts. So what happens is, like in the case of laser interferometer, the laser head measurement receiver. So the laser head's measurement receiver will detect the part of the returning laser beam and the Doppler shifted frequency components. So what happens is, during a measurement, the laser beam is directed through optics. During a measurement, the laser beam is directed through the optics in the measurement. So what happens is laser head measurement receiver, the case of laser head, okay, in the case of laser head measurement receiver, during a measurement, okay, during a measurement, the laser beam, during a measurement, what happens is we have a laser beam, okay, during a measurement, the laser beam is directed through optics, okay, during a measurement, the laser beam is directed through optics in the measurement path and then return to the laser head is measurement receiver, which will detect the part of the returning beam and a Doppler shifted frequency component. So what happens here is, in the case of a laser head measurement receiver, what happens is during a measurement, always in the case of during a measurement, the laser beam is directed through the optics in the measurement. The laser beam is directed through the optics in the measurement and then returned to the laser head is measured and receiver, which will detect the part of the returning beam and a Doppler shifted frequency component, and always a Doppler shifted frequency component. Then what happens like the measurement displays, it always contains, okay, it always contains a microcomputer to compute and display results. So with respect to the laser heads measurement receiver, it is a receiver, the name itself says, it will detect the part of the returning laser beam and a Doppler shifted frequency components. That's what the main thing. It will detect, okay, to optics and the measurement of path, then return to the laser head measurement receiver. That's what happens. So the fourth one is the display, the measurement display. In the case of a measurement display, it contains a microcomputer. It always contains a microcomputer to compute and display the results. It always contains a microcomputer to compute and to control the results. Okay, that's what happens. So it contains a microcomputer to compute and display the results. The signals from the receiver and measurement receiver, the signals, okay. So it contains a microcomputer to compute and display results. Okay, it contains a microcomputer to compute and display the results. It always contains a microcomputer to compute and display the results. The signals from the receiver and measurement receiver located in the laser head are counted into two separate pulse converter and subtracted. What happens over here is, in the case of a measurement display, it contains a microcomputer, okay, it contains a microcomputer to compute and display results, okay, to compute and display results. The signals from the receiver and measurement receiver, the signals from the receiver and measurement receiver located in the laser head are counted into two separate pulse converter and subtracted, to a separate pulse converter and subtracted. Then calculations are made and the computed value is displayed. Calculations are made and the computed value is displayed. There are other input signals for correction are temperature, coefficient of expansion, air velocity, etc., which can be displayed. So this is what happens with respect to the measurement display, where it always contains a microcomputer. Okay, it always contains a microcomputer. Okay, it always contains a microcomputer to compute and display results. To compute and display results. Okay, then the signals from the receiver and the measurement. So the signals from the receiver and the measurement receiver are received located in laser head are counted in two separate pulse converter and subtracted. So then what happens? Two separate pulse converter and subtracted. Then necessary calculations are made using a microcomputer. The computed value and the other corrected input signals like temperature, coefficient of expansion, air velocity, etc., are displayed. This is what happens in the case of a measurement display. Okay, so this is what happens in the case of a measurement display. So we'll just sum up. So what today we have discussed, what do you mean by interferometer, then what's the requirement, then we have discussed about laser interferometer, okay, then we have discussed about the various components of laser interferometer and its functions. All this have been discussed today, okay. So this is what happens over here. Okay, then I'll just stop for today. Okay.